Okay, today we're working with a lab titled How Enzymes Function, and if you'll notice what they begin with on this lab, they discuss two ways that enzymes can actually work. One is to cause a degradation, sometimes referred to as a degradation reaction, meaning that we're going to break a larger molecule into two smaller molecules. Whatever we begin a reaction with, we typically refer to a substrate, but we only refer to it as a substrate if an enzyme is involved in the reaction. And if you do not use an enzyme, whatever you begin the reaction with is called a reactant. But in this case, we will be using an enzyme, so what we're starting with, the starting substance, will be referred to as a substrate. And it will bind to the enzyme. And if you'll notice, what we're actually going to do with this is I will draw and the molecule that we're going to introduce, which is the substrate, is going to look, that is introduced into indentation right here where that substrate will fit. It's not an exact fit, but it is what they call an induced fit model, so that when that enters, then the enzyme may change shapes a little bit in order to make it then have an exact enzyme. This is the substrate, and so it's going to go into that. Let's say that we do that. It goes in. Happen. This substrate will literally and those two units will be released. So what I have created is one unit that would say, well, let's say would look like this, and the molecule, which would actually be a product. We had the single substrate. So we started with one substrate, it went into the enzyme, it's called the enzyme substrate complex. So we have complex the enzyme substrate. Okay, and what is released are, so these are the two products right here. What we began the reaction with, of course, would be the substrate. Now, once these two components leave the active site, once they're no longer, then that enzyme can be reused. It is a reusable large protein, three-dimensional shape. It can be reused. Eventually they do wear out, and then they have to be remanufactured, but they can be reused over and over and over before they do wear out. Okay, so we've taken a large molecule, which would be our substrate. We have produced two smaller molecules. In this case would be our two products. So this is what we call a degradation reaction. We've actually broken it apart, so that's a okay. The other type of reaction that they're describing is one where we have two small substrates, and then what I want to do is I want to add those two together. So this is a substrate here. This would also be a substrate here, and again we're just going to use the same enzyme. And some enzymes are reversible. They can actually catalyze a reaction where you break substrates into two substrates, or they can actually add two substrates together to make a single product. So once again, these substrates will enter into the enzyme, forming the enzyme substrate complex, and then the enzyme once again changes shapes so that it will match those two substrates, and then that substrate, once it has been assembled into one molecule, is released, And so what we have created then is just one larger product. In this case, this thing here would be our product. So we're putting things together. We have two small substrates. We're adding those together, and we're creating one larger product. And so this is called a synthesis, to build. That's what the term actually means in Latin. So this would be a synthesis type reaction versus a degradation type reaction, which is what we have on the opposite side. So we can either break substrates apart. That would be a degradation reaction. We can add substrates together. That would be a building process, which would be a synthesis reaction. Okay, so that's what we're working with today. We're working with enzymes. We will also be working specifically with an enzyme which is called catalase. And catalase is something that we all have in our cells. If you were to cut yourself, then many times someone would put hydrogen peroxide on the cut. A lot of people do that, and what that actually does is to create some bubbling activity, and that bubbling activity will eliminate any bacteria that you may have introduced into that cut and pull that. I think I'm misspelling this, but that's okay. Spell it correctly. So notice that anything that has a suffix ending in an ASE, that tells you automatically this is going to be an enzyme if it ends in an ASE ending. Okay, and then our substrate in this case, so this is the enzyme. What we begin the reaction with, of course, is our substrate, and our substrate here is going to be a hydrogen peroxide. Well, that's actually H2O2, whereas water is just H2O. This is H2O2. That means this has one more oxygen atom than does water. So what I do in this case is I'm going to begin, and then if I'm going to have a reaction, that arrow means reacts to form, and then I'm using an enzyme called catalase. Now, where we get this catalase is actually out of a potato, which potato cells have catalase in them, just as our cells will have catalase. And what it does is break the hydrogen peroxide into oxygen gas, which of course what that does is bubble out. And of course if we're using it on a wound, it will pull out the bacteria or the dirt or whatever we've introduced into the wound. And the other thing that's created, all right, so that's not a balanced equation, but I'm not too concerned about that at this point. We could balance it. We could put 2 coefficient. That actually gives me 4 oxygens. Coefficient of 2 at this point would give me 4 oxygens. Coefficient of 2 right here would give me 4 hydrogens and 2 oxygens. So it's still not balanced. Anyway, I'm not going to worry about balancing that equation at this point. But we did actually take the hydrogen peroxide and we did break it from a large molecule. So whatever that would look like, it went into our catalase, and then we'll use that again as an example. The H2O2 went into this, and this is the enzyme. H2O2 would be our substrate, and then what came out of this would be 2 products. So we created oxygen plus H2O. So what we've done is take a larger molecule and break it into two small molecules. Actually, we're creating water, so we're not recreating hydrogen peroxide. We've created oxygen. We've also created H2O2, so we now have 2 products. So again, the hydrogen peroxide, that would be my substrate, and my oxygen and water, these would be my products. And again, that enzyme is reusable. So if we're taking a large molecule, breaking it into 2 smaller molecules, This type of reaction is what we call a degradation. So we have that type of reaction process. All right, degradation reaction. From a larger substrate to two smaller products. These, of course, will be my products that we have created at the end of that. All right, so that's really what we'll be doing. But we're going to test the effects of different things. Like, for example, we're going to test the effect of, let's say, well, the first one is just specifically catalase activity. So we have, in one tube, we had catalase and hydrogen peroxide. Well, that, of course, should break down into, the hydrogen peroxide should break down into water and oxygen. The oxygen will create bubbles, and, of course, that will create some foaming. And then in the second tube, that will be the control tube, because we put hydrogen peroxide, but we didn't put in catalase. So catalase will break down hydrogen peroxide, but water will not break down hydrogen peroxide. So we know that will give us no response whatsoever. So that is the control tube. In the third tube, you have catalase and sucrose. Well, catalase breaks down hydrogen peroxide. It does not break down sucrose. So we don't expect anything at all to happen in that. So nothing should happen in that tube. The other thing that we're working with would be the temperature, the effective temperature on catalase. So in tube 1, we have catalase in that, and we're going to use a cold incubator or warm bath, and then in the third tube we're going to put that tube into a boil. So we have a cold temperature, a warm temperature, and a boil. I want to see how well that enzyme works. So you're going to have an put catalase. And we're going to find out how well that by measuring how many bubbles of oxygen are created. So if you create a large number, then obviously, and if it works best at a warm temperature, once again, you will create more bubbling in this tube than you would in the cold temperature. And then also, in the hot temperature, you know, this is boiling water. Now, if you put a protein in boiling water, basically we should denature the protein. That's called denature. So if I have the catalase and the hydrogen peroxide in the third tube, so this is tube 1, this is tube 2, this is tube 3. So if I place that in tube 3 and put it in the boiling water, our enzyme, that one should actually change shapes to the point that is not functional. So this is called has its natural form, and if it is denatured, it shouldn't cause a reaction at all. So this one actually should show no bubbling whatsoever. If I've spelled that correctly. So no bubbling because we've denatured the enzyme. So and that should work. Unless you put it in the water bath before it's boiling, that one actually should work out just fine. The other experiment you're working is catalase in different concentrations. So if you'll notice in tube 1, it says you have 1 centimeter, and mark the tube at 1 centimeter and 5 centimeters. So the first mark, you'll put water. The second mark, you put hydrogen peroxide. Well, of course, once again, catalase will break down hydrogen peroxide. Water will not break down hydrogen peroxide. So tube 1 is going to be your control. Nothing at all should happen with that one. Okay, then go to tube 2. So we have, again, we've marked it the 1 centimeter and the 5 centimeters. So to the first mark, which is 1 centimeter, you have catalase. To the second mark, you have hydrogen peroxide. So these, you have 1 centimeter. That is that is the catalase. So that is your enzyme. To the 5 centimeter mark, all of this will be hydrogen peroxide. All right, that's tube 1. Tube 1 is no, actually it's tube 3. Yeah, this is tube 3. This would be tube 2. Tube 1 was the one where we had water plus, we had water in there, plus you added hydrogen peroxide. Well, of course, you shouldn't get any reaction out of that whatsoever. Water will not break down hydrogen peroxide. So that, again, is the control tube. We know we'll get a negative response out of that one. Okay, so we'll see what we get out of the second tube. And tube 3, what you've got is you will put 3 centimeters, so 3 centimeters of hydrogen peroxide, and then 3 centimeters catalase, and then at the 5 centimeter mark, so this is 3 centimeters of catalase, we've just increased the concentration of the enzyme, and then at the 5 centimeter mark, you'll put hydrogen peroxide. And we need to see which one of these will catalyze the reaction more quickly. Would it be the one with fewer enzymes, or will it be the one that has a greater concentration of enzyme? So does concentration affect the rate of enzyme? Okay, then where we're doing the effect. So you have, here we have another test tube, and this is tube 1. So we're going to put in water. So we're going to mark 3 tubes at the 1 centimeter level, at the 3 centimeter level, and also at the 7 centimeter level. Okay, and so then it says fill each tube with 1 centimeter of catalase. Okay, so we have 1 centimeter of catalase in the first centimeter, and then fill to the second mark in the first. So we're going to place just plain water up to the 3 centimeter mark, and then we're going to, and this is adjusted to pH 3. We won't adjust it to pH 3. We'll just add plus, let's say, 3 drops of hydrochloric acid. That should be plenty to reduce the concentration, HCl. This is an acid. So that water has been adjusted to make sure that it is acidic. And then to the last centimeter, we're going to put hydrogen peroxide. So into this, we'll put H2O2. All right, that's 2. And then in tube, on this one, once again, we have a mark at 1 centimeter, another mark at 3 centimeters, and then another mark at 7 centimeters. And the first mark, once again, we have catalase. And this tube 2, catalase. And then second mark, which is at 3 centimeters, we're going to put water at a pH 7. So this is water, pH 7. So this is just distilled water is what that will be. And then to the third mark on this one, we will put hydrogen peroxide like we have done on the other two. So we'll fill that with hydrogen peroxide. Okay, you have to work with. Line the 1 centimeter mark, a line at the 3 centimeter mark, a line at the 7 centimeter mark with catalase, and then this, of course, is the third tube. Second mark, the 3 centimeter mark, we're going to put water. This is going to be adjusted with a base. So it will be H2O, plain water, plus we're going to put in, let's say, 3 drops of sodium hydroxide, which is a base, NaOH. All right, so 3 drops of that. Okay, and then to the last centimeter mark, which would be the 7, we're going to add our hydrogen peroxide. So really what we're looking for here, if you compare the 3 tubes, the tube has an acid in it, so it's an acidic situation. So does catalate work best in an acidic situation? You do have catalase, you do have hydrogen peroxide, so will catalase break down the hydrogen peroxide in an acidic situation. In the second tube, we do have our enzyme catalase, and we do have our hydrogen peroxide, but this is at a pH 7. So this catalase work best at a pH 7. And then in our third tube, we do have enzyme catalase, and you do have the hydrogen peroxide, but in this case, we've added a base in the water. So in this water, we've added sodium hydroxide, which is a base. So will it work best in an acidic situation, tube 1, or in a neutral, which is pH 7, neutral situation? Acidic, anything below 7. Neutral would be at pH 7. And then in tube 3, this is a basic situation, which would mean anything above pH. That would be a basic situation. So we're going to see which one produces the greatest amount of bubbling, and that's what we're looking for. And whichever one that is, that then that will determine whether catalase works best in an acid or a base or a neutral situation. So we have basically just 3 different experiments.